Hello friends, this is Dharmeen Patel. Welcome to the lecture series of Mathematics 2. In this lecture we will discuss about the Fourier integral. It is very similar topic to the Fourier series, but Fourier series is applicable for periodic function. This is applicable for non-periodic function. Fourier integral is very important to develop the Fourier transform and Laplace transform. Let us see the study of Fourier integral for non-periodic function. Fourier integral of non-periodic function fx defined on minus infinity to infinity given by fx equal to integration 0 to infinity a omega cos omega x plus b omega sin omega x d omega. Here omega is a positive real number and a omega equal to 1 upon pi integration minus infinity to infinity fx cos omega x dx, and b omega is 1 upon pi integration minus infinity to infinity fx sin omega x dx. Here Fourier integral of non-periodic function fx is a integral expansion of fx in terms of omega, and a omega is actually integration of fx and cos x with respect to x. B omega is also integration of fx and sin x with respect to x. We will see the how to find a omega and b omega with this example. Here fx equal to e raised to minus bx, where x and b both are positive. We have to find the Fourier integral of fx equal to e raised to minus bx. So first of all we write down the Fourier integral formula. Fx equal to integration 0 to infinity a omega cos omega x plus b omega sin omega x d omega, where a omega is 1 upon pi integration of minus infinity to infinity fx cos omega x, and b omega is 1 upon pi minus integration of minus infinity to infinity fx sin omega x dx. Now we find the first a omega and then find b omega. Let us see how to find the a omega. Here a omega is 1 upon pi integration of minus infinity to infinity fx cos omega x dx. Now we put the function fx, but fx is only e raised to minus bx, which is only valid for x greater than 0. So here we are define our function fx equal to 0 for x negative, and if e raised to minus bx when x is positive. Here our function is divided into two parts. If our function is negative then it is 0, and if it is positive then e raised to minus bx. Now we can write a omega like 1 upon pi integration minus infinity to 0 cos omega x dx plus 1 upon pi integration 0 to infinity e raised to minus bx cos omega x dx. Now for the second integration we are applying this integration formula. E raised to b ax cos bx is equal to e raised to ax upon a square plus b square a cos bx plus b sin bx. Now first integration is 0 and second integration is applicable by this formula. Then a omega equal to 1 upon pi e raised to minus bx upon b square plus omega square into minus b cos omega x plus omega sin omega x, where limit is 0 to infinity. As we know that e raised to minus infinity is 0, so upper limit of our integration is directly 0, which is given in the red color. So finally a omega equal to 1 upon pi minus e raised to 0 upon b square plus omega square minus b cos 0 plus b omega sin 0. Here sin 0 is 0 and cos 0 is 1. So finally after putting this value we get the a omega equal to b upon pi into 1 upon b square plus omega square. Now we will find the b omega. B omega is 1 upon pi integration minus infinity to infinity fx sin omega x dx. Now our fx is divided into two parts. So our b omega is 1 upon pi integration minus infinity to 0 dx plus 1 upon pi 0 to infinity e raised to minus bx sin omega x dx. For second integration we are taking the integration formula, which is integration e raised to bx sin bx dx equal to e raised to ax upon a square plus b square into a sin bx minus b cos bx. Now after applying this integration formula, we get the b omega equal to 1 upon pi into e raised to minus bx upon b square plus omega square into minus b sine b omega x minus omega cos omega x dx, where limit is 0 to infinity. Now as we know that e raised to minus infinity is 0, so upper limit of this integration is directly 0 and b omega will be 1 upon pi minus e raised to 0 upon b square plus omega square into minus b sine 0 minus omega cos 0. Here cos 0 is 1 and sine 0 is 0. Finally after putting this value, we get the b omega equal to omega upon pi into b square plus omega square. Now we have a omega equal to b upon pi into b square plus omega square and b omega equal to omega upon pi into b square plus omega square. After putting a omega and b omega in this integration, we get the fx equal to e raised to minus bx equal to 1 upon pi integration 0 to infinity b upon b square plus omega square cos omega x plus omega upon b square plus omega square sine omega x, which is our Fourier integral of our function e raised to minus bx for x greater than 0 when our b is positive. Now we will see the second example. Find the Fourier integral of fx where fx is 1 for mod x less than 1 and fx equal to 0 for mod x greater than 1. That means our function is 1 between minus 1 to 1. Here we will see the graph of this function. Here function is 1 between minus 1 to 1, so its graph is look like between minus 1 to 1 our function is constant value 1 and function is 0 when mod x greater than 1. That means when x is greater than 1 our function's value is 0, as well as x is less than minus 1 function's value is also 0. Now we can see that function's graph is symmetric about y-axis, so our function is even function. Therefore we can say that b omega is directly 0 and a omega will be 2 by pi integration 0 to infinity fx cos omega x dx. Now we will calculate the a omega because our b omega is directly 0. Now we will find the a omega. This is the formula of Fourier integral and we put the b omega equal to 0 because our function is even function. Therefore fx equal to 0 to infinity a omega cos omega because our function is even function. Now a omega is divided into two parts, therefore it is 2 by pi integration 0 to 1 fx cos omega x dx plus 1 to infinity fx cos omega x dx. Here function's value is 0 for x greater than 1, so second integration is 0 and in the first integration we will put the fx equal to 1, so finally a omega equal to 2 by pi integration 0 to 1 cos omega x plus integration 1 to infinity is directly 0. Now after calculating this integration we get the 2 by pi integration 0 to 1 cos omega x, that is after putting the limit we get the 2 by pi sine omega upon omega minus sine 0 upon 0. As we know that sine 0 is 0, so finally we get the a omega equal to 2 by pi sine omega upon omega. Now b omega is directly 0 as we know that. Therefore finally Fourier integral of fx equal to 2 by pi integration 0 to infinity sine omega into cos omega x upon omega d omega. Now we will see the exact value of functions at 1 and minus 1 because our function is discontinuous at 1 and minus 1. Here Fourier integral is given by fx equal to 2 by pi integration 0 to infinity sine omega into cos omega x upon omega d omega. Now take the 2 by pi on left hand side with fx, then we get the integration 0 to infinity sine omega into cos omega x upon omega d omega equal to pi by 2 fx. Now we multiply our function fx with pi by 2 like this. Therefore integration 0 to infinity sine omega cos omega x upon omega d omega equal to pi by 2 into 0 between minus infinity to minus 1. Between minus 1 to 1 our function is 1 and 1 to infinity it is 0. Now how to multiply it with pi by 2? Therefore, we can see that here our part of the functions are like this. Now, how to find f of minus 1 and f of 1? Let us see. Here, f of minus 1 is obtained from average limit of fx at minus 1. That means f of minus 1 equal to limit x tends to minus 1 fx plus limit x tends to minus 1 plus fx by 2. This is the left hand side limit of minus 1 and left hand side limit of minus 1. Here we are taking the average of right hand side limit and left hand side limit at minus 1. Now, after putting the function's value on left hand side and right hand side, we get the limit x tends to minus 1, 0 and limit x tends to minus 1, 1. Now, our limit of 0 is 0 and limit of 1 is 1. So, finally, we get the f of minus 1 equal to 0 plus 1 by 2, that is 1 by 2. That means f of minus 1 is 1 by 2. Similarly, we can find the f of 1. Here we are taking the average of right hand side limit and left hand side limit of 1. After putting the function's value of right hand side limit and left hand side limit, we get the limit x tends to 1 minus 1 plus limit x tends to 1 plus 0 upon 2. After simplifying that, we get the 0 plus 1 by 2, that is 1 by 2. So our f of 1 is also 1 by 2. Now we have a f of minus 1 is 1 by 2 and f of 1 is also 1 by 2. Now we will put the f of 1 and f of minus 1 in this Fourier integral, and after putting the value of f of 1 and minus 1 in this Fourier integral, we get this first result, which is integration 0 to infinity sine omega cos omega x upon omega d omega equal to pi by 4 at exactly at minus 1 and pi by 4 equal at x equal to 1. Now we find the second result by taking x equal to 0 in this integral. Then we get 0 to infinity sine omega upon omega d omega equal to pi by 2. X equal to 0 is lies between minus 1 and 1. So we are taking the pi by 2. The final result is 0 to infinity sine omega upon omega d omega is equal to pi by 2. So in this lecture we discussed how to find the Fourier integral for continuous as well as discontinuous functions, and in the next lecture we will discuss about the Fourier cosine and sine integral. Thank you very much.